We've done that before. All right. All right. Steph, take it away, baby.
Okay, so on lesson 7, preparation assignment, number 3, letter B, I was going through all the videos that Brother Kroner, is that his name, was doing, and I was taking all kinds of notes and just kind of reviewing everything. I was saying earlier, I want to make sure I have a good foundation in all of this, and I'm trying to just get my bearings, really good. But I cannot figure out in the video and other, I remember briefly doing the percentiles for the population, but I cannot remember how to do that.
How to solve when it asks you to find like the 75th percentile or something like that? Okay.
Yeah.
So
this one is, do you have a copy of that there?
The prep assignment?
Yeah. Do you want me to read it to you?
I can pull it up really quick. Preparation assignment. And you said it's letter 3B?
3B.
B, okay. Let me pull that up. Is this part 1 or part 2?
This is part 1.
Part 1? Okay.
You have to use the applet.
Right.
I have that pulled up too.
Okay. So part 1, 3B. What is the probability a randomly selected individual observation is between 5 and 50? Oh, I'm looking at A. What is the 40th percentile for this population? Okay. So the way that we solve for percentiles is you're going to go to the normal probability applet.
Okay.
And if you look at the applet, there's the area box at the top of the curve.
Mm-hmm.
And you're just going to type in 0.4 for 40th percentile.
It's seriously that easy.
Yeah.
Yeah, and then you're gonna shade to the left of that first z-score. So the z-score should be so yeah, I guess I kind of got back, because before you even put in the number, just shade to the left of that first red line, and then go ahead and put in 0.4, and the z-score on the bottom left-hand box should say negative 0.253. Do you have that?
Hold on. Sorry.
Oh.
Sorry, what did you say? Negative 0.253?
Yeah, negative 0.253 should be your z-score.
Oh, okay.
And then once you have your z-score, you're going to plug that in to your z-score equation. So let me go look at the problem here and see if it tells us any other information we need to know.
It doesn't give us
the information in the reading assignment to complete these questions. I wonder what information in the reading assignment it's talking about.
Well, for this one, you just end up using the z-score, the standard z-score, not the one with the sample size.
Oh, it gives it to you right here. So in question number 3, it tells us that the mean is 10 and the standard deviation is 5.
Yeah.
And so we're going to use that information now. So let me write this down. So our mean is 10 and our standard deviation is 5.
Mm-hmm.
Okay. And so you know the z-score formula where it's so z equals x minus mu over standard deviation?
Yeah.
So we're going to take that z-score that we just got, and we're going to plug all that information that it's given us, our z-score, our mean, and our standard deviation, and we're going to plug it into that equation, and then we're going to solve for x, since x is the only thing that we don't know. So we get negative 0.253 equals x minus 10 over 5. And so then we kind of work it backwards, because you know how usually we know x and we're trying to solve for z to get our z-score, but since we already have our z-score, now we're going to kind of work it backwards and solve for x. And so how we're going to do that is we're just going to take negative 0.253 and we're going to multiply both sides by 5, so we get rid of that 5 out of the denominator. So we take negative 0.253 multiplied by 5, and that gives us negative 1.265 equals x minus 10. So have I lost anybody yet? Am I moving too quick?
I wish I had a whiteboard that we could look at and write it all down.
I wonder if I can pull something up, actually. It might look a little...
Because I remember when Patty showed us the factoring, when you have the different formula. Patty, do you remember that? When you showed,
that's just like what you did, but we did it with the formula beforehand, so it ends up being x equals, what is it?
I swear we were
Five
doing.
times z plus mu. For
Yeah,
quantity.
and you can do it like that if you want. If you can.
You just convert the
Factor.
formula so your unknowns on the left and everything else is on the right.
Right. Yeah, you're free to do that if you'd like, so that you can just plug it in and then solve that way.
One makes your brain hurt less.
Yeah, honestly, like if that works better for you, yeah. So in that case, it would be -23 times 5.
Yeah, 5 times the
Yeah, it
negative
works out pretty
3
much, yeah,
plus
the
10.
same.
You still get the 8.7.
Yeah, 8.735. Yeah, exactly. So however you want to do it, as long as you are solving for x, then yeah, it comes out to be x equals 8.735, and then that's your answer. It just wants to know what x is, what observation correlates with the 40th percentile.
Does that make more sense? Did he explain it differently so that it makes more sense for you?
Yeah. Yeah, it does.
If not, if it's confusing, you can always go back and watch the video for lesson 5, and Brother Komar, maybe you might have like something where you can show you like on a whiteboard or something like that, where it would be more a little bit more explanatory.
Okay.
Yeah, those tutorials are super helpful when you sit there going, I think, I don't know, and then I watch them go, oh, okay, I was doing right.
Yeah.
Seem a lot easier for sure.
That's how I was feeling yesterday. I was totally lost. I was trying to do this.
Did you finally understand what you're doing, or do you need more help?
Well, I need help when we get to the part 2.
Okay.
One of the questions. I just spent forever on it and still.
Okay. Were you guys good on C, D, and E on number 3?
Yes.
Yeah.
It's all standard formula, and then like E, we did those ones the other day. We just
Minus
huh?
Yeah.
when you take the difference.
This one, it's greater than 8. Wait, it's less than 8 or greater than 12, so it's just what's on either side. But because it's balanced, it's just double what one of them is.
Okay.
Fast.
Add the 2 sides of the applet up.
The 2 outsides, you just add those 2.
Okay. Yes. Yes.
They're going to be the same. Both the left and the right are going to be the same area.
Yeah.
Yeah.
Okay.
Okay. You guys ready to part 2?
Yes.
All right. So, this is number 4. The sample size of n equals 4 taken from the normally distributed 2011 sales data. What's the shape of the distribution? It's normal because the parent population is normal.
Yes, I agree.
Easy peasy. Number 5. Go ahead.
Samples of size n equals 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution? And it would be normal because the size is large and it is normally distributed.
Got both of them. All right, Steph?
A sample size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X bar is less than 40? And if, is it the same rules that if it's normally distributed, it's going to be normal?
Yeah, but now we're going to solve for we're going to get a number out of this one. So this is where we have to use that formula, but the one that's in 6 and 7. Where the z-score is the x minus mu over the standard deviation divided by the square root of the sample size.
Okay.
So my question is, why wouldn't, because you want it less than 40 and not equal or less to 40, why wouldn't it be 39 minus 45 on your top?
It's just less than 40. I don't know.
Colby?
So what it's asking is, all right, so if we look at the the information, like kind of the summary at the beginning of part 2. So it says, suppose pair computing sold an average of 45 P phones per minute in 2011 with a standard deviation of 10, and they looked at their sales to determine if they're normally distributed. So what it's asking is, what's the probability? We are on 6, right? What is the probability? Yeah. So we're taking a sample size of 4 phones. We're just going to look at 4 like sales, I guess, and what is the probability that the observed, I'm guessing, their sales would be less than 40. So the 40 doesn't have anything to do with sample size. It's just asking, what's the probability that the sales that we observed that at that moment, I don't know if it's like that month or what, well, per minute. Okay, so at this minute it would be less than 40. So
it's not matter if it's 40. It's just that one is not crucial. So it's just.
Yeah. So it would be 40 minus 45 on the top, right?
Yep.
Correct.
And then over 10 divided by the square root of 4?
Yep. And so just to simplify that, we know that the square root of 4 is 2, and 10 divided by 2 is 5. So if you want to just have an easy way to solve it, it's just 40 minus 5 over 5. And
-1.
Right. Because 40 minus 5 is -5, and -5 over 5 is -1. So that's our z-score. And now we just need to plug it into our applet. And because it's asking if it's less than 40, we just shade to the left of -1 z-score.
Which gives you a 0.1587.
Perfect, yeah, we're done.
Okay, so, and then, well, on the answer key, it says something about the probability about, or P1 minus PX, or something about that. That doesn't have anything to do with it.
What?
Yeah, I don't think
what are you looking at?
This was on the answer key, because I was having so much trouble getting this one. So
okay.
then...
Let me see if I can find that.
Let me pull up the answer key here.
Number 6.
Yeah, I don't see anything on the answer key about 1 minus x or anything.
Well, it
like
says
that.
z minus, or z equals -1 probability.
And that equals about 0.16, which is rounded of the 0.1587. So 0.16 using the 68, 95, 99.7 rule, or 0.1587 exact. But what does that have to do with anything?
Well, I think it's a formatting issue. I think put a return after the -1, put probability on the next line, and I think that's what it's saying. I think those are just 2 different statements. Is that what's throwing you?
My answer key must be different, because all mine shows is it just says probability equals about 0.16 using the 68, 95, 99.7 or 0.1587 to be exact. So maybe mine's just different. I don't know. I don't see that anywhere.
This is what ours says. Here, I'll share my screen.
Yeah, let's see. Oh, okay. All right. So it tells you your z-score and then the probability.
Yeah, but it had it originally on the same line.
Oh, I see.
It looks like
mine's all on the same line together.
I see.
Yeah. So it looked like
okay.
It looked like that. So it looks like maybe.
Okay, yeah. So now that it's on 2 different lines,
it's separated to 2 different lines. I think it was just a formatting thing. I think that's all.
Gotcha.
I'm like, that doesn't make sense to me what you're saying. All right.
Okay.
All right.
Weird.
All righty. So we good? Let's go on to the next one, or you guys need to do? You guys.
Yep. On to the next
All
one.
right. Okay. So with the sample size of n equals 4 taken from the normally distributed sales, what's the probability that the observed x bar is greater than 35 and less than 55? Or both, and the truth is they're the exact same distance on either side of the mean. So it's just negative 2 and 2.
So which would be in the 95th percentile because it's 2 standard deviations.
Yep. But
Okay.
and then plug it in with the negative 2 and 2, you get
Right.
area is that's you just highlight that little area, and it's 0.9545.
Mhm. So yeah, once you get your z-score of 2 or negative 2, then you wouldn't even, if you know your 68, 95, 99.7 rule, you wouldn't even have to plug it into the applet if you didn't want, because we know that 95% of the data is 2 standard deviations away. So
Unless they're looking for us to be really specific on decimal points.
yeah,
or something.
sometimes, yeah, exactly. It's just like a generalized rule, but yeah, sometimes if they want to get more specific, it's always a good idea to plug it in.
Okay. So number 8, are we ready?
Yep.
A sample size of n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that x is greater than 41 and less than 49? So I have 41 over 45, 41 minus 45, and that's over 10, which is over the square root of 25, which ends up being negative 2. And on the other side, I have a positive 2. Everybody, same thing.
Yeah, story here.
So ended up about 95% since we are 2 standard deviations away.
Yep.
Okay.
All right, Stephanie.
Am I up?
You're up.
Yep.
Number 9.
Number 9.
Okay. A sample of size n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that the observed x is greater than 50?
Do you know how to do that?
No.
Okay. So we plug all the data we have into the formula. So you end up with it's greater than 50, so that's our x. So it's 50 minus 45 over 10 divided by the square root of 5, or 25. Which is
25? Okay.
So then you end up with 5 over 2 after you do all the math, which is 2.5 for your z-score. So you plug that in for your z-score.
Okay.
Highlight the right side because it needs to be greater than that. And the area gives you 0.0062.
Yes. Okay.
So you have that, Stephanie?
Yeah, I just plugged it in there, and that's what I got too.
Okay.
You understand how you got it?
Yeah. You guys just go faster than me.
No problem. We just want to help you though, so that you don't feel.
Well, I thought that we do part 2 as a group, and so where you guys, I haven't done it because I was waiting. I did part 1, and so you guys are just faster. So I hadn't even, to be honest, read through this yet because I was reviewing everything else, and so yeah.
You're fine. I just kind of look through it ahead of time just so that I know what I'm doing, so I don't get on here and go, I don't know, and we spend an hour trying to figure it all out together.
Exactly. I ran out of time, honestly. That's what my goal was, but I was spending all the time reviewing everything.
No, don't worry about it. You're fine.
I'm good. I'm catching up. We're good.
Yeah, you're doing great. Okay, so we're on number 10. So sample size of n equals 4 are taken from a right skewed 2010 people and sales data. What's the shape of the distribution of the X bar? It's going to be right skewed because there's not enough data. It's only a sample of 4, and with right skewed, it's not going to even approach normal.
Yes. Okay. Are you okay, Stephanie? Okay.
This is like the other one he talked about with what was it about? In the video. But anyway, the internet usage for college students and how it was way off to the right. 7. So anyways, that's what that one.
Okay, number 11. Samples of size N equals 40 are taken from the right skewed 2010 P-phone sales data. What is the shape of the distribution of X? So it's approximately normal because the sample size, or the population size, is large enough. The parent population.
So the sample size
Right.
of the parent population is large.
Yeah. Okay.
Why would you guys consider 40 of the sample size be enough? How do you know that? Because if it's out of like millions or something or a lot, how would you know that 40 is big enough?
So the general rule is if it's greater than 30, we're going to say, regardless of the parent population, even if the parent population is right skewed or left skewed, the book says, just as a general rule, if the sample size is greater than 30, then we can say it's approximately normal, regardless of the distribution of the parent population.
Oh, okay.
So just remember that as like a rule of thumb.
Okay, I'm going to write that down.
Joe, 3, Joe.
Somebody wants Carolyn.
Yep.
Sorry, my phone keeps ringing, so
Worries.
I'm going to take it off the hook.
No problem. No, I was in a meeting yesterday, and my dad called me twice, and my mom called me once, and I'm like, okay, they never call me 3 times in an hour, both of them.
That's when you go, is something wrong? But
Well, I sat down at the meeting finally and called him back. I'm like, what's going on? What's happening? And my mom's like, oh, I just thought I missed your call. And I'm like, okay. Like, I'm like, Dad, what's going on? Oh, I just need your address. I'm like, seriously?
ask Mom.
For 4 years. How do you not have my address?
Oh, that's fun. Okay.
Well,
We are on number 11. No, 12.
you're up.
Yeah.
Hold on. Our cat has decided to join us. Okay. Ready. Number 12. Okay. Is there a theorem that justifies your answer to question? What is the name of the theorem? And that's what Colby was just talking about, right? The sample size large enough, so it would be the central limit theorem. Is that what that has to?
Central
Yep,
limit.
that's right.
Yep.
Okay.
Yeah. Okay.
All right. Number 13, the sample size N equals 4 is taken from the right skewed population or 2010 P-phone sales data, and you want to know the probability of the observed X bar less than 35. Can you compute the probability using the normal probability applet with the information you have, and why? Nope, because it's not a normal distribution, so it's skewed, so you can't use that. You can't figure it out yet.
Yeah. Okay, hold on just a second. Okay.
You good?
So we can't figure it out because the sample size isn't big enough, and
No.
it's right skewed.
It doesn't. The sample size is not really the biggest part of it. It's just it does not have a normal distribution, so it doesn't matter how big your sample size is. Well, yeah, I guess it does. It's got a small sample size, but it's yeah, you can't do it.
So, and it has to be both, because if the distribution was right skewed, but you had a big enough sample size, you could do it,
Right.
Yeah.
right?
Yes.
Okay.
Mm-hmm.
Okay.
I got stuck on the right skewed. I forgot the fact before.
Okay. So number 14, a sample size of N equals 36 is taken from the right skewed 2010 P-phone sales data. What is the probability that the observed X is greater than 36.5? So I have 36.5 minus 40,
Mm-hmm.
and that is 3.5, and that's over,
Negative 3.5.
yeah, negative 3.5. That's over 12 divided by the square root of 36.
Mm-hmm.
Which is 12 divided by 6, which equals 2. So I have a negative 3.5 over 2,
Mm-hmm.
which is negative 1.75.
Mm-hmm.
So then it would be 95.99.
yeah. That's what I've got.
Okay. All right. Are you there, Stephanie?
Mm-hmm. Negative 1.75. That's what you said. Okay.
And then when you plug that in, you get
So the probability that the observed, Colby, do you say X bar, or what do you say for that?
X bar is just a symbol for sample mean. You can call it X bar. It's fine. But what it really means is the mean of the sample that we've taken. So that weird little funky U symbol is the mean of the entire population. The X bar symbol is just the mean for the sample size that we have, the sample that we took out of the population. Does that make sense?
Oh, so the mean, that's when they say the mean of the means?
Right, yeah. So like if I wanted to know the mean height of BYU Idaho, my entire population of BYU Idaho, then the little U symbol would be the mean for the whole campus. Now if I just took a sample of 100 kids from BYU Idaho and found the mean height of that group, then that would be X bar.
Okay, got it.
So, and then when we're reading it, though, you should say X bar and not just X.
Yeah, you can call it X. Yeah, that's fine. You can refer to it whatever. As long as you know what it stands for, you can call it whatever you want.
Okay.
If you were reading this question, how would you say it?
Yeah, I just usually just say X bar, just a little bit faster than saying sample mean, I guess.
Okay. Okay. All right. Number 15. You guys ready to move on? Are we good?
Yeah.
Okay. A sample of size n equals 36 is taken from the right 2010 pPhone sales data. What is the probability that the observed X bar is between 37.5 and 42.5? Okay, help me out with this one, guys. Sample size 36.
Well, you're gonna find the z-score for each of them, but you're gonna
and then minus them,
the
right?
same spread from each other. One's to be negative, one's positive. It ends up, you just plug it in. So you like for the 37.5, it's 37.5 minus 40 over 12 divided by the square root of 36, which gives you negative 2.5 divided by 2, which gives you a negative 1.25.
Okay, wait just a minute. I was trying to write down the other one too, so I got lost a little bit. So 37.5 minus 40 divided by 12 divided by the square root of 36, right?
Yep.
Yes.
So square root of 36 is 6, and divided by 12 is 2, and 37.5 minus 40, what is that?
Gives you a negative 2.5.
5. So,
Negative 5 divided by 2.
2. So negative 1.25, right?
Uh-huh.
Yeah.
Okay, so that's for 37.5, and then do the same thing for 42.5.
And to simplify, 42.5 minus 40 is 2.5. So you're going to end up with the exact same thing, but it's positive.
Oh, that's right. Okay.
All the math. If you look at, once you get there, you're like, oh, that's all the same stuff.
Yeah,
So
exactly.
So then when you have those, you can plug in your z-score of negative 2.5 and just highlight the middle area.
I have a dumb question for you, Colby.
Okay.
So we have a normal probability applet. Is there another applet later on down the road that's right skewed applet or a left skewed applet?
Nope. If it's right skewed or left skewed, there's nothing we can really learn from it. Like that one question we had in 13. Unless the distribution is normal, there's not a lot we can do with that data. Because it's so skewed and it's not normal, there's not really a lot we can infer from it, so we really don't deal with that ever. So we just use the normal probability applet.
Okay.
How are you guys doing? You guys good to go? You want to go do the quiz thing or the group?
So the probability, can we finish this real quick? So we did the negative 1.25 and 1.25, and if that's the z-score. And if I type that in, are we trying to find the area between those two? So only highlight the middle area.
Yep.
Yeah.
Right? So it's 0.7887, so we'd run up probably to 3. So 0.789 is the probability.
Yes.
Is between that. Okay. Okay.
You good?
Yeah. Just writing some stuff down. Okay. Now we go to the quiz, right?
Yeah.
Little group meeting.
The quiz, what is this? It's just a group thing.
Yeah. It just feels like a quiz a little bit. Hey, it even calls it a quiz.
All right.
Okay.
All right. So using the number 3, using the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left z equals negative 1.358. Round your to the nearest 3 decimal places. So you just plug those into the curve. So it's 1.358. What was the question? I forgot.
To find the combined area under the standard normal curve that is to the right of 1 point.
To the outskirts, not the insides.
And to the left.
Okay, so if you just do
0.175.
Yeah, 0.175.
3 decimal places. Okay.
Wait, it wants to know the right, well, hold on, the right and the left added together. Okay, 0.1745. That's, okay.
Yeah, so round it to 3 spots, Carolyn. 3 decimal places.
7.5 then. 175. Okay.
Everyone's number 4.
The United States Coast Guard assumes the mean weight of the passengers in commercial boats is 185 pounds. The previous was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weight of a random sample is 40 commercial boat passengers were recorded. The sample mean was determined to be 177.6. Pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean, than was observed in the sample. Round your answer to 3 decimal places. Example, if the answer is 0.8976, you would then enter 0.898.
Okay.
Oh gosh. Okay.
All kinds of good stuff.
We talked about this question in our meeting this morning, and that last part where it says find the probability that random sample passengers will have a weight that is as extreme or more extreme, either above or below the mean, and was observed in this sample. Like, they've tried to reword that question so many times to make it less confusing, but it just sounds really confusing. What that really means is it's just a two-sided test. So once we find the z-score, we'll just round to the left of the negative one and to the right of the positive one, which it's trying to say. It just says it really confusing way.
Very wordy.
Yeah, it's very wordy.
How about more than?
Yeah.
Less than. All right, so we end up with, let's see, let's pull out our information. So it's saying the population means 185.
Yeah, standard deviation is 26.7. The random sample's 48.
Mm-hmm.
And the sample mean is 177.6.
Yeah.
So for the formula, I have 177.6 minus 185.
Uh-huh.
Is that what everybody else has? Okay, over 26.7, which is over the square root of 48.
That's what I've got.
Okay. All right now.
Okay.
All right, so
I think I did that wrong.
What'd you do?
I don't know. Remember how we did it that one time and our calculators let us punch it in all at the same time?
Yeah.
And then I don't know what I did that time to make it work, but it's not working now.
Okay. Well, let's do the math. The top 177.6 minus 185 gives you a negative 7.4.
Uh-huh.
And then when you do 26.7 divided by the square root of 48, I got 3.854. And then,
Okay. But the square root of 48 would be 6.928.
Yeah, well, it's 6.928. Yeah.
I
Okay.
just punched it all together. Let me see.
Yeah. You remember you have to put the number and then the square root. You have it, so you'll do 26.7 divided by 48, then hit the square root button. That'll give you your number, and then you got to plug that back in. Do the 7.4, negative 7.4 divided by the 3.854.
Well, I have to do the square root button first.
You do? Oh,
Yeah.
mine I put it after. Otherwise, it square roots the number I just put in.
No, yeah, it does it after. Well, I have to type it after, but then it does it. No, I mean I have to do it before. Sorry.
As long as you know your process, it works.
Exactly. So negative 7.4 divided by 3.854, right?
Yep.
Just my fingers didn't work. 3.854. Okay, so negative 1.920.
So I forget what the question was again. Probably the Renaissance. Are they above or below the mean? So it could be both the left and the right.
That's what I did. So then the area would be 0.2828, so 0.283.
Huh?
Did you do to the right and the left, Carolyn?
Of the negative 1 point.
Okay, maybe I have the wrong z-score.
What'd you get for?
Negative 1.074.
Yeah, I got 1.92.
Okay. Okay, obviously I have my math wrong.
No problem. Is that what you get? Did you get, or Stephanie?
I got negative 1.920.
Okay. All right. So yeah, so you have a z-score of negative 1.92, and it's to the extremes of each side, right? Colby, are we on the right track?
I think so. I'm trying to find my work. I'll just have my answers from what I already plugged in yesterday. So
0.0549.
oh yeah, it is negative 1.92. Yeah, that's the right z-score. So.
So
I have something wrong. Okay.
Maybe because you had the square root of 48. You said was 6.928.
Okay, I got it. 1.921.
920.
Well, are we going to round up?
Well, mine was negative 1.9200, and then like some other numbers after that. So if I rounded it, it would be 0.
Okay, I have 1.9205, but maybe that's because I rounded my. That's probably because I rounded my one I square rooted. My what do you call it? My random sample. That's probably the difference there. Okay.
Well, even if you round the random sample, that was 48. The square root of 48 is 6.9282, so you wouldn't round that up.
I'm not sure. Something happened, but I'm not sure what it was.
Well, okay, I wonder if it's you rounded it at all, like you just did 6.928 divided by rather than the full number that like goes out like 10 numbers, dividing 26.7 by that long number. Because I did that a meeting or two ago. I didn't round it. You guys did, and so I got a barely different than you guys.
You had like a 0.4 and we had a 0.2 or something.
Yeah, it was just barely off. I think that's probably what happened.
And that's going to be the difference.
It can be, yeah. So, but basically, but for this one, if we all got negative 1.92 for the z-score, so if it's the extremes, it's going to be both the left and the right.
Yep.
Which gives the probability of 0.0549.
Yeah. So we would round to 0.055.
Yeah. You on the right track there?
What's that?
Okay, we on the right track?
Yeah. What did you guys get for the final answer? Sorry, for 16. I just spaced off a bit. Which one's it?
For 4, we got 0.055.
Oh, that's your guys' Oh, it must have mixed them up. That's like my number 16. That's why I got so confused as you guys jumped right into that when I was like, yeah, that's right, 0.055.
It's number 6.
Yeah, so it's all mixed up. That's bad.
All right, no worries.
Number 16, we don't even have a number 16.
You guys probably only have 15. They give us an extra question because on campus, it's like, did you complete part 1? Did you complete part 2? Did you meet with your group and complete the quiz? Or like 1, 2, and 3 for our prep quiz. So they're a little bit off. But yeah, you guys got the right answer.
Yeah, we just if we did our stuff and if we actively participated.
Yeah, we just have 2 questions in the beginning. Okay, so now we are on number 5. Are we good to move on?
Yes.
Okay, number 5. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Okay, which of the following? What? I'm sorry.
Okay, so this one's kind of confusing.
Thank you. And I was like, why not I get it?
You're not it.
So there's 2 options really, and then the third one just like cannot be. So the first one is just the distribution of the individual observations, which is like what we did in like chapter 5 or lesson 5, where we just did x minus the mean divided by the standard deviation. And now in this last lesson we've introduced sample means versus just population means. So really the first one, the distribution of individual observations, has to do with like the population mean.
Mm-hmm.
And then, so we know with sample means, we have to take our standard deviation and we have to divide it by the square root of our sample size. Mm-hmm. And so that's automatically going to make it smaller, right? If we have to divide, if we take that number, like say our standard deviation is 10 for our population mean, but then when we incorporate it into our sample mean, we have to divide it by the square root of the sample size. So that's going to make it smaller. So yeah, so the distribution of sample means x bar what is always going to be smaller than the standard deviation of just individual observations.
See, that makes sense.
Doesn't that kind of
do the math? I don't know.
there's a short little paragraph in the reading that talks about that to remember that the standard deviation in your sample means is always going to be smaller than the standard deviation of just your individual observations.
Okay.
Does that kind of have to do with what you explained earlier when I asked the other question, when you were talking about heights of BYUI students?
Right, yeah, exactly.
Okay.
All right, so number 6. Which of the following results implies that the spread of x bar decreases as the sample size increases? Normal distribution,
Increases.
Increases. That would be the. Why is this one confusing me? It shouldn't be.
Colby, explain each one of this.
What is this? You guys on number 6?
Yeah, which of the following results implies that the spread in x bar?
Oh, okay.
As the sample increases.
Mm-hmm. So with the spread, because so it's the law of large numbers, and I'll explain why. So the law of large numbers basically says that as sample size increases, that's going to decrease our standard deviation, but it's also going to bring x bar, which is our sample mean, as closer to our population mean. And so that means that the spread decreases, because it's pretty much the same question we just asked, because if we have a smaller standard deviation, we have a less spread in our sample mean.
Yeah.
So basically, if you think about it, if I take 10 and I have to divide it, like our standard deviation, let's say it's 10, and I have to divide it by the square root of our sample size, the larger my sample size is, the smaller my standard deviation is going to be, right? Because if my denominator is getting bigger, then my standard deviation is automatically going to be smaller. For example, like 2 divided by 4 is going to be a lot bigger than 2 divided by 10. So if my denominator gets larger, then it's always, my standard deviation is always going to get smaller. So sorry if I'm slaughtering that, but so basically that's what the law of large numbers states, is that as our sample size increases, our standard deviation is going to get smaller, which means that and standard deviation is literally just a measure of spread, how spread out the values are from our mean.
Yes.
So anyways, sorry, that was kind of a long way to describe that.
No, I like that. I need details. It helps me learn, so that's good.
Well, that's good.
Okay.
That was actually, that was awesome, because it really, I mean, now that you say it, I'm like, well, duh, that's exactly what it says, but for some reason in my head, I'm like, I don't know, what's it asking me?
Right.
That's how
I'm going to pick the central limit theorem.
Seriously, that's what we did the other day. It's going to be this one. Why? I don't know. I like that one better.
I'm glad we changed it, though. Then we got 100%, I think. So.
Yeah. Okay.
All right, you're up, Carolyn.
Okay, scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and standard deviation of 8.8. Use this information to answer questions 7 through 10. Diane earned a score of 160 on the quantitative portion of the GRE. What's the z-score corresponding with Diane's score? We have to round it to the 3 decimal places.
So it's
okay, so we got to plug it into our formula again here, and hope I can do my math right.
We don't have a sample size. This is just this standard, basic formula. What did you get?
Wait, I'm slow.
Oh, sorry.
Oh, go ahead. But I haven't got my answer yet.
Did you do 160 minus 150.8 divided by 8.8?
Yep.
Okay. I'll wait for Carolyn.
Okay, so I got 1.04545.
Yep.
So if we're going to round it, we're just going to drop off. It's going to be 1.045.
Yep. That's what I got. Are we right, Colby?
Yep, that's right.
All right. All right, I think it's my turn. Okay. Number 8. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So, above 160. So first find the z-score, and then we're going to plug it in, right? To get the area.
We just found this.
We already have our z-score, right?
Yeah.
Okay.
We did that in the last one, so we'll just plug that into the applet.
Okay. This is okay.
Oh.
So if it's above 160, are we only looking on the right-hand side of the right line, or the red line, I mean? So I got the area of 0.148.
That's what I got.
Yep.
Okay.
Colby, tell us if we're wrong, okay?
Okay.
All right. So for the next one, it says, for number 9, a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What's the z-score corresponding to the sample mean of these students' scores? So, which one is this? This is the one.
You first have to find the mean of those scores.
Those scores, and then
Okay.
those scores, and then plug it in, or do we have to do each one individually?
No,
That'll
you just find the mean and then go
And then the
from there.
sample size is 5, so it'll divide. No, that way,
So
yeah.
160 is the mean of those 5 scores. Is that right?
Yeah, 160 is the mean, yes.
All right. What's the z-score corresponding to the sample mean of these? So then you know the mean, and so then you just redo the.
Right, so you'd set it up as 160 minus 150.8 divided by 8.8 divided by the square root of 5.
Which was what we already did on number 7. It's the exact same thing. So it's 1.045.
No,
Well,
because we're taking the standard. We have a sample size now of 5.
right.
So it's
So we have
it's
to
gonna
do
be
the
different.
extra.
divided by square root of 5.
Oh,
That's what was. That's yeah. Come on, phone, work with me here.
all right.
All right, you guys got that one yet?
Is this almost?
I want to know how I did this all in one thing without having to. How did I do this last week?
I don't know.
Because I don't like having to retype everything.
I just hit the square root after I hit the number I'm square rooting, and I can finish the problem that way.
Okay, I'm ready.
All right, you ready, Stephanie?
No. Well, almost. I was just still trying to figure out my dumb calculator. I mean, my wonderful calculator. Okay, 9.2 divided by.
I'm gonna order a charging cord for my daughter's graphing calculator.
Okay, did you guys get 2.334?
I got 2.338.
I got 2.338 also.
Oh, sorry.
Yeah,
No, it is 8. It's 8. I
Yeah.
don't know why I even said that. I was rounding up the second 3 for the third number. Okay, so the z-score is 2.338 on
Yeah.
number 9.
That's what we got.
Sorry guys, I hate to bail, but I gotta go sit in on a class now that I had TA for here on campus. So
Thank you.
we're doing good so far. So
Yeah.
good luck with the rest of the quiz. And thanks for letting me sit in with you guys. I appreciate it.
Thank you for all your help explaining
Yeah.
stuff.
Yeah.
See you
guys.
later.
See ya.
Bye.
Okay. All right. I think we're on you, Carolyn.
Oh, okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer to 4 decimal places so that they will have greater. So we would plug it into the applet,
Yeah, plug that score into the applet.
and then you want
2.338, right?
2.338. And just the right side.
So, well, that's why they said 4 places because of that. So,
yeah.
0.097.
009.
Okay.
All right.
Okay.
Oh, my turn, right? Sorry.
No problem.
11. Okay, so now we got some new data here. Suppose that the mean GPA of BYUI students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn.
Okay, so that means that the mu is 3.5, the sigma is 0.7, and the n is 81. Oh, the U thing, the little the cool little symbols.
Mm-hmm.
I have to write them down when I go to plug them in later. I'm like, which one was that again?
Okay, so we are going to use the same equation, right? Of
But it just wants to know the shape of the sampling distribution for this question.
oh yeah, okay. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of the 81 students who are selected? What is the shape?
Approximately normal. You know why?
Why?
This is 81. It's got a high sample size. Doesn't matter if it's normal or not. It starts off left skewed, but because the sample size is 81, it's going to approach normal.
Which is more than 30, which is what Colby talked about, right?
Yes.
Okay, that makes sense. Okay.
You all good on that?
Mm-hmm.
Okay. All right, so number 12. What is the mean of the distribution of the sample means for the X bar for all possible samples of size 81 that could be drawn from the parent population? And we go to 1 decimal place. So, what is the mean of the distribution of the sample means? So that's where we use that formula. So let's plug it all in. So it ends up being, wait a second here.
Wait, which formula is that again? Mean of the sample means?
Mm-hmm.
So,
Probability of a mean response.
Mm-hmm. So we need to know, let's see here.
well, what is your guys' formula, though?
Well, what's my,
Huh?
Z equals, I don't know if you can see, wait. Can you see that?
Hold it up. Yes, hold it up. Okay, that formula. You have to talk, though, so we can see it, Patty, because you have to make it go.
Oh,
Okay.
is Patty showing it?
No, you're showing it, but I couldn't see.
Okay,
Yeah,
so
that's-
Z equals X minus the mean over the standard deviation,
divided by the sample size.
Sample size.
which is square rooted.
Mm-hmm. Now the only question I have is, okay, so we're going to do this, but we don't have an X and we don't have a Z.
Yeah. Okay, so can we solve for...
Well, it's not asking.
We did that last... Didn't we do that last time?
Well, this is a whole new bunch of data, so because the other data was for 7 through 10, or whatever, through 10. So now we're doing the GPA BYUI students, 2.5, standard deviation is 0.7, 2, what is the mean of the distribution of the sample means?
Wait, so the mean is going to still be the 3.5. Because it doesn't.
What about, I think we're missing our variable.
Well, we don't have to
What we're
plug it in, remember, because when the rules of finding a sample mean, it says your mean is going to be the same as your sample mean will be the same as a population mean. Regardless, it's the deviation that changes.
Okay,
So
the 81 minus 3.5.
Hold on, I gotta find my notes here. It says, no, it's gonna, remember it says the distribution of a sample means when a parent population is normally distributed. This is when it's not normally distributed. Where did it go? Where did I write this down at? Here it is. The shape that's when you get the central limit theorem. So as it gets higher, the closer to normal it gets. But the center, if the mean of the original population is mu, then the mean of the distribution of sample means is also mu. So it's going to be the same. the mean of the population is the same. It's the standard deviation that will change. So the standard deviation is where you have to figure out the difference. And that's where you take the
So you think that it goes on for the mean of the distribution of sample means. So the 81 instead of the entire BYUI students is 3.5. So you're saying that 81 is going to be the same as all of BYUI students?
Yes. I'm writing it down. I'm writing it down so I can show you. So, and then it has which is, what is that stuff down at? All right. Let's see if you can see that. Okay, so remember when it was talking about the sample size, it says, so like this, it won't come up on my it won't go big on my screen.
No, I have it written down right here.
But in the notes, did you see how where it said that? It says, so with the sample population mean, the sample mean of the population is the same as the population, which in this case is 3.5. But the standard deviation, when it's not normally distributed with a sample, is going to be the population standard deviation divided by the square root of the sample size. So it's going to be 0.7 divided by the square root of 81. But for the next one, sorry, I'm jumping ahead. But for this one, the population of the sample, or the mean of the sample population, is the same as the standard population.
Yes.
Does that make sense?
Yep, I have it written down right here.
Okay.
I didn't understand what it was telling me before when you wrote that down. So.
Yeah.
So is that a rule? Is that the central limit theorem, or no? What is that one?
It's for finding the area. What does it say? It says, with the distribution of a sample means when parent population is not normally distributed, it says the shape is determined basically by how large the sample is. Unless it's a high number, it's not going to be something you can figure out. But it's going to approach normal when it's higher, which is the central limit theorem. The center is always going to be the same. The mean of the sample population is the same as the sample as the other. When you're not given the extra data, that's what you use.
Okay.
And the spread of the standard deviation, is going to be it's sigma divided by the square root of the sample size. Or the standard deviation divided by the square root of the sample size. So the standard deviation of the population divided by the square root of the sample size.
You're on number 13 right now, right?
Now I'm going to number 13, yes.
Yeah.
Sorry. Are we all good where we're at? Know what we're doing?
I did 3.5 for 12 because it's the same.
Yes. Yes.
Okay. I'm like, if I just got that wrong, then you just explained everything for nothing.
Okay.
I am like.
Okay.
So if I plug in my number 0.7 over the square root of 81, and then I get this 0.7777 number, that's the answer. 0.0.
I'm on 13 right now, Carolyn.
It says
I'm on 12.
No, for 12. What you're just figured out is the standard deviation.
You just figured out 13.
You just figured out 13. That's the answer for number 13.
Okay.
It's 0.078 when you round it off to 3 decimals.
Wait.
0.7.
Okay, 0.078. Yeah. Okay, so now I'm lost on what is the... It would be this...
From the notes, it was telling us that with sample... I have to read it again because for some reason the words aren't sticking in my head. When you have a sample, distribution sample means when the parent population, it doesn't matter if it's normally distributed or not normally distributed. When you're doing sample means, the mean is the same as the population.
As a parent population.
The parent population.
So it would be 81?
No, 3.5.
Or the 3.5?
It would be the 3.5. The 3.5 is the mean, and the standard deviation is the
0.7.
0.078. Okay.
So when you figure out the standard deviation of the sample, it's going to be the parent population's standard deviation divided by the square root of the sample size.
Okay, and I did find that I had that written in my notes, but it's just like here, who knows what it goes to. Okay.
Yeah, go look at the PowerPoint, and it's actually written in the PowerPoint. It says each of those on there.
Okay.
The samples.
Okay.
It does the samples on there.
Patty, in the PowerPoint, what?
In the PowerPoint, it works some examples, whether it be if it's normally distributed or not normally distributed. It works some samples, some sample problems, but it actually shows you. It says this is what the shape will be, and the central limit theorem comes into effect. This is from lesson 6 on that part. Because we're not converting. Let's see here. Because lesson 7 is just about finding z-scores and stuff and probabilities using the information that we found in lesson 6. It's just the same formulas and just plugging into the applet. It just tells us how to find the probabilities in lesson 7. So this is all the same stuff as lesson 6. And in lesson 6, if you look at the stuff where it talks about the distribution of sample means, regardless of what, and then it shows you what the parent population is normally distributed and if it's not normally distributed. And in both cases, it describes the shape, the center, and the spread and how you find them. And shape is determined by the population size, or by the sample size, basically. If it's normally distributed, then it's just normal.
I want to click on it, but if I do, it will...
Open another window and do it. You can actually have a second window open at the same time. Just don't close the one that you're taking the quiz in.
Yeah, I've done that before. I learned that before. That's why I'm scared to do anything. It's okay. I can do this after we're done, guys. I just...
Here, I can pull it up if you want and show you and share my screen.
Okay. I'll look at mine and you can share yours too.
Okay. I just got to get it to open, so give me just a sec.
Do you guys have any classes in the new, the 3.0 iLearn yet?
One.
Yes.
I don't have any with that yet. Is it hard? I haven't had to do it yet.
Until I switched to the grid for the reading all the posts, that helped, because before I was on the grid, I'm like, I don't know what I've read, what I haven't, and it keeps saying I have all these messages I haven't read. I'm like, what in the heck is going on? So.
And I don't know what's from what, because this is my first time. So I guess I'll try and switch to the grid.
Well, if you're not in 3.0, you don't have to worry about it. Are you in 3.0?
I have my nursing classes in 3.0, and then I have this in 2.0.
Go in there and, yeah, switch your setting.
Okay.
Makes a huge difference, I promise.
Okay.
Okay, so which PowerPoint are we looking at? The spread of distributions?
Okay, I screwed up and I'm pulling up him talking to us. Shush, dude, don't talk to us. Okay, let me go. Let me undo this. I'm going to go back just to the PowerPoints in the course and pull that up. That makes more sense.
That's where I'm at.
Yeah,
Wait.
so I was trying to do this the hard way.
Where are you at? Oh, under course and then resources and lesson PowerPoints.
Yeah, which one is this? It's called sampling distribution.
Well, I thought it would be the sixth one down, spread of distributions.
Yeah, that's what I'm pulling up here.
Hey, how's your daughter, by the way?
She's good. She's still taking her meds, her pain meds, so she's lots of fun. She was hilarious. Hilarious. But yeah, she's doing really good. She was really puffy and swollen, and she's bruised, but she's doing okay.
I forgot to tell you to keep ice on it like constantly, like put a little right here and there. But
yeah,
we used a pillowcase and put like the frozen peas in the pillowcase, 2 of them on each corner, and then kind of twisted it so that it was 2 little corners of the pillowcase, and then just kind of put it on there, those like together, like so they won't slide in as much, and
oh yeah.
Bandage. Oh yeah, it was lots of fun. But
yeah, we've been doing that like
fun with the swelling and the pain. It helps a ton with the pain.
Yeah.
The frozen peas
Yeah.
melt too fast.
Okay.
All right. This is what we did for. These are the sample. This is the PowerPoint for lesson 7, I guess. But we're looking. We want to look at not normally. Hold on. Sorry, I got to figure out which screen it is.
Well, I need to pull. So it's the fine probability and sampling. That's the PowerPoint that you're looking at.
So that was. Yeah, I'm actually this. It's actually not that one. It's the one before it, I believe. Hold on. Okay, that's not it either. What the heck? Which PowerPoint is that? Am I not sharing anymore? Where'd it go?
No, you stopped presenting.
I don't know what I don't know that I hit anything, but something happened. Okay, I don't know where the PowerPoint that had all that information went, but it literally set it up step by step, shape, how you find it. So this is.
Was it in the other, like the video tutorial and not in the...
Yeah, but those were all in here, but I just can't figure out which one it was.
Oh. Because I only watched the YouTube, but I didn't watch the other...
PowerPoint?
The PowerPoint, the YouTube PowerPoint, but then I think there's also like a video tutorial I watched one week.
Yeah.
But I didn't watch it this week. I don't even know if it's attached this time.
It's in there.
There is a couple videos this week.
Yeah, they have them in there each week.
No, those ones I watched, but then I'm going to go look and see if what I'm...
Here's what I'm going to do. We're going to just mute him so that we can't hear him, and I'll scroll forward through that so they get to that page that we want.
So yeah, like step 4. I don't usually do those where it says the video tutorial. So there's a lesson 7 part 1 and lesson 7 part 2.
I do those. That's what I always do.
And then did you watch the video tutorials? Is that where it might be?
Not the video tutorials. It's under...
Oh, okay.
Which
Right.
part are you in now, Patty?
I'm just trying to find part that I want to show you because it explains this. But you know what? Just go back and watch that because I can't find the stinking slide that it says it on, and I can't do it from here because it won't let me change it. So basically, somewhere there's a PowerPoint. We have to find it that tells us all this stuff. But basically, what it's saying is, it says the shape. The shape is what changes based on your sample size.
Mm-hmm.
The larger the sample, like if it's either normally distributed, then it's a normal curve. If it is not normally distributed, if you have a high enough sample size, then you're going to get approximately a normal.
Yes, I remember that.
That's what the shape for the distribution of a sample mean. The center of a sample mean, regardless of if it's normal or not normally distributed, is then the mean of it's the same as the distribution. The distribution sample is the same as the population sample.
Okay.
Okay?
Okay.
And then the spread is going to be the spread of a sample distribution is going to be the standard deviation of the population divided by the square root of the sample size.
Okay.
So
Okay.
for number 12, basically, if you follow those guidelines, it's going to say that the center or the mean is going to be the same for the sample distribution, the sample means, same as it is, it's going to be the same as the population mean.
Okay.
Now, based on my notes, that's what it means. That's what it says. And so for 13, we already did that one. So you understand kind of where that's coming from?
Yes.
Okay. All right, so number 14 then is what we're on. So what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So now we need to figure out based on 3.3. So this is where we actually go back and actually use the formulas and plug them in. Here it is. So this is where we need to find our z-score. So z is going to be equal to 3.3 minus 3.5 divided by 0.7 divided by this, which is divided by the square root of 81. Does that sound right to you guys?
My computer turned off, and I'm just now coming back. So, you guys moved on.
Did it kick you out of your quiz?
No, the laptop turned off. It had low battery, and then it just decided to turn off at 10%. I'm like, no, I had enough battery to get through the rest of the quiz, but I unplugged it a while ago because it runs across where I walk, the power, and I didn't want to rip it out and drop my laptop. But yes, now I know if it gets below 10%, it will just kick me out. So I just rejoined.
Well, welcome.
Okay, so you guys are on review here. So you're on 14.
We're on 14. So it's saying the probability that the mean GPA for 81 randomly selected students will be less than 3.3. So
Okay.
the z-score.
Get the z-score. So it's 3.3 minus 3.5.
Uh-huh.
3.5 is the mean.
Yep.
Divided by 0.7, right?
Divided by 0.7, which is divided by the square root of 81,
Which is
the sample.
Sample size. Okay.
How you doing, Carolyn? Are you getting there?
Yeah. I think I have my z-score negative 2.574.
I got negative 2.571.
Okay, let me try my math again here.
I'll do mine again too, just in case, because I'm not sure which one of us is on.
I'm wondering if you plug it into the applet, if it's that much different.
Yeah.
Okay.
Did you guys get negative 2.571?
That's what I got.
Okay, I figured out how to do it all at the same time on my stinking calculator. Use the parentheses. Duh.
That's what you're going to have to do to...
Well, because you're trained to, anyways. The 0.7 divided by square root of 81, that itself needs to just be in parentheses because you want to solve that by itself before you divide it. So now I can solve things a lot faster.
Okay.
For you guys.
Yay, congratulations. All right. So did you recheck your math, Carolyn? Did you get the 2
Well, yeah, if I keep putting sevens in for like 10 sevens, then yes, I get to, if I need to stop rounding, I guess.
What I do on those now is I round it to like 5 decimal places so that way I'm not losing extra spots.
Yeah.
Okay.
But yeah, then we end up with negative 2.571. Once you plug that into the z-score, with the z-score on the applet and do everything, what was the question? It was less than that, right?
Yeah.
Less than 3.3, which gives you 0.0051. So 0, 0.
My applet.
Huh?
Can't find my applet. Oh, wait, wrong thing. Sorry. Okay, here we go. Okay, what are we trying to solve here? What is the probability that the GPA is less than 3.3? So you're only going to highlight the left area of the left red line?
Yeah, for number 14.
So is it 0.0051?
Well, that's good.
Yeah, we're only going to go 3 decimal places out.
Yeah.
Carolyn needs to go to bed. I'm sleepy.
Can you see it?
Her brain is shutting down.
Sliding down the table.
And,
Okay.
Carolyn!
We'll let you go.
One more thing. Is it my turn or whose turn is it? Doesn't matter. I'll do it.
Doesn't matter.
What is the probability that the mean GPA for 81 randomly selected BYUI students will be greater than 3.3? So do the z-score of that and then...
Well, it's the same thing we just did in 14, so all we have to do is highlight everything to the right of it instead of everything to the left.
Yeah, because it's the same...
Or subtract that from what we got from the other one for 1. For 1.
So it would be
The same...
0.995.
So it'd be 0.995. That's what I got.
Okay.
Wait.
But
I'm glad you guys are here, because I would have only done the opposite and only plugged in the very, very right-hand side. But you found the z-score of the 3.3, and that's that part. So I see what happened. I'm glad you guys are here. I would have got that wrong. I did it. 0.995, right?
Yeah.
Yeah.
And together, those two add up to 1.
Mm-hmm.
Okay. Are you guys ready to submit?
Yeah.
You guys good to go? Let's do it.
Yay.
Thank you, Colby, on the couple that we went, huh?
All right. Colby was here.
All right. I'm going to bed because I've got to go back to work tonight.
When are we meeting again next? Are we going to do a double up next week, or are we going to do Friday this week?
I can do either.
Okay. Do you guys like doing, I think it's easier if we break them up, even though finding two can be tricky sometimes.
I think that I kind of like. I thought I wanted them together just so it's hard to meet up both times. But this is almost an hour and a half of one, so that's going to be 3 hours, and to try to learn everything. And I don't know. I can do either one, but I'm kind of leaning toward meeting on Friday.
I think meetings is more beneficial because number one, you're only going over one set of information, and we don't take forever. But though some of them are easy.
Yeah.
But number two, I think it also, here, let me stop the broadcast and then we can chat. They don't care.